Now the topic is numerical solutions to differential equations. Numerical solution to differential equations. Differential equation. Here consider a first order, first order, first degree differential equation du by dt equal to f of t comma u, du by dt equal to f of t comma u with the initial condition u of t naught equal to u naught. This is u of t naught equal to u naught. Take this as completely equation 1. Du by dt equal to f of t comma u with this condition. Equation 1 is called an initial value problem. Here what is the thing here? The differential equation is what? First order, du by dt, first order, first degree, equal to function of t comma u, f of t comma u, du by dt equal to f of t comma u. And since it is first order differential equation, its solution contains one arbitrary constant. To evaluate that arbitrary constants, I require one condition, that is the condition is imposed at what point? Initial point t naught, u of t naught equal to u naught. This is called initial condition. That is why this entire problem, this equation 1 with this condition, is called initial value problem. Okay, now to solve this problem, when you write like this: when equation 1 does not possess exact solution, equation 1 does not possess exact solution, then an approximate solution is required. Then an approximate, or what is that, numerical, an approximate solution is required. Okay, for that we have methods. Okay, there are two methods, there are two numerical techniques, there are two numerical methods or techniques to solve equation 1. What are those? First one is single step methods, and second one is multi-step methods. Okay, now so whenever the differential equation do not possess exact solution, we required an approximate solution. To find that solution, there are two numerical methods were developed, and one case is for single step methods and another case is for multi-step methods. Let us see what are these methods. The first step in getting or obtaining, in getting a numerical solution, of the differential equation 1, is to partition means division, is to partition the interval, one can write a comma b, which is equivalent to a, one can take t naught, initial starting point t naught we have taken in equation 1. Therefore a is taken as t naught comma b, on which, on this interval, solution is required, on which the solution is desired, comma, partition this interval into a finite number of subintervals, by the points, what the points here? t0 less than t1 less than t2 less than and so on less than tn, and the tn is nothing but b, and this is nothing but a. This is nothing but a. These points are called the mesh points. These points are called the mesh points or the grid points. Mesh points or the grid points or the nodal points The space between this means common difference. The space between the points is given by what is the space? It is denoted by hj. Hj defined as the difference between tj, that's subtract difference between tj minus tj minus 1 for j equals to 1 to n. That is, one can write first one. If I put 1, h1 is nothing but t1 minus t0, h2 is nothing but t2 minus t1, and so on like this, okay. And this is called, this hj is called which is called mesh spacing or step length. Mesh space or step length. Now if I take the mesh space as constant, if we assume that the points are spaced uniformly, that is meaning of what? Hj is nothing but a constant value. That means the difference between t1 minus t0, t2 minus t1, everything is h. That means the data points are equally spaced. Hj equal to h, which is equal to constant, for all j. Then the uniform mesh points are given by that means equally spaced mesh points. Uniform mesh points are given by this is tj equal to t0 plus ih, tj equal to t0 plus jh. J is from 0, 1, 2 and so on n. For your idea, I am giving this one. That is, let me write here, that is t0. If I put 0, t0 equal to t0. What is t1 equal to? t0 plus h. What is t2 equal to? t0 plus 2h, right? t2 is at a distance of 2h units, from t0. Similarly, t3 is t0 plus 3h and so on like this, okay. This is the definition for equally spaced mesh points. Tj equal to t0 plus jh. Now in numerical methods, we determine an approximate. An approximation. We determine an approximation uj to the solution u of t. What is this? Tj is approximation to original solution u of t at the point tj. then the set of numbers, what are those? Uj, for one can say that is uj, that is u0, u1, u2 and so on, un. This set of numbers uj is called numerical solution, to the initial value problem. Numerical solution to the initial value problem. Just these are the notations. What is this? U of t is exact solution and uj is numerical solution. Uj is numerical solution of the initial value problem equation 1. Initial value problem equation 1. And let us see one by one method. I think you know the Taylor series expansion. Okay, let me write in next slide. Now the Taylor series of u of t in the interval t minus h less than or equal to t less than or equal to t plus h is, one can write like this, u of t plus h. What is this one? Taylor series u of t plus h into u dash t, right, plus h square by factorial 2 into u double dash t and so on. Lastly somewhere h to the power of p by p factorial u pth derivative of t and so on. Similarly u of t minus h, what is this Taylor series? U of t minus h into u dash t plus h square by factorial 2 into u double dash t minus h cube by factorial 3 into u triple dash t and so on. And this pth term minus 1 whole to the power of p, h to the power of p by p factorial pth derivative and so on. Okay, these two are the equations. Let us adding these two equations. If I add these two equations, what I am getting, see, adding these two, or one can say take this as better, you take this as 2, take this as 3. From equation 2, what I am having, u of t plus h equal to u of t plus h into u dash t plus in the remaining all the terms, what is the least power of h? H square. So one can write order of h square. Isn't it? Okay. Better you write like this. Don't say order of h square. You write like this. One more term, h square by factorial 2 u double dash t and so on. This implies what I am getting, u of t plus h minus u of t equal to what? H into u dash t plus h square by factorial 2 u double dash t and so on. Let us take h common and take on to the left side, u of t whole by h equal to what? U dash t plus h by 2 factorial u double dash t and so on, right? So what I am getting finally, this implies u dash, okay, u of t plus h minus u of t by h equal to u dash t plus what is the remaining terms, in the remaining terms what is the least power? H. So one can write u dash t is equal to order of, this is order of h, u dash t equal to u of t plus h minus u of t whole by h. This is of what order? Order of h is called forward difference approximation. To u dash t first derivative, and one can write this is, take this as 1 2 3 4, and this 4 also can be written in our forward this is what? Forward difference operator, u of d by h plus order of h. Since this represents forward difference, this approximation is called forward difference approximation to u of t. And now from equation 3, what I'm having, u of t minus h equal to u of t minus h into u dash t, right, plus h square by factorial 2 into u double dash t, and so on. Now let me take all these terms here, h into u dash t plus h square by factorial 2 u double dash t and so on is equal to what? Sorry, this is minus. Take these all terms to left side, then this is, take this u of t minus h to the right side and take h common, u dash t minus h by factorial to u double dash t and so on is equal to u of t minus u of t minus h whole by h. So one can write u dash t equal to u of t minus u of t minus h by h plus order of h. That means in all these terms, least power is h, therefore order of h, and this is called backward difference approximation. Backward difference approximation to first derivative. This is equation 5 you take. Why it is called backward? Because this difference u of t minus can be in terms of backward difference operator del plus order of h. That is why this u dash t formula is called backward difference operator. Another one, and the last approximation, adding equations 3 and 4. That means u of t plus h minus u of t minus h is equal to, what I'm getting, u of t plus h, u of t minus h is equal to 2u of t, first derivative terms gets cancelled, and you will get h square by 2 factorial plus h square by 2 factorial. So h square u double prime t, isn't it, right? And the triple derivative terms cancel, and you will get 2 h power 4 by 4 factorial fourth derivative t, and so on. Then yeah, one can write subtract means what? No, you will not get this, terms. If I subtract, I will get odd terms, u of t gets cancelled, and h, that is 2h u dash t you will get, plus 2h cube by 3 factorial u triple dash t you will get, from this what I'm getting, u dash t you write by taking 2h common, well, then you will get u of t plus h minus u of t minus h whole by 2h, plus the remaining terms will be order of h square, u dash t. This is u dash t, this is called what? And one can write this u dash t, this is equation number 6, u dash t, this is central difference, delta of u of t by h plus order of h square, central difference. Equation 6 is called central difference operator, central difference that's it, central difference for first derivative u dash t, So finally what I am having, how many derivatives we are having finally? So finally what is u dash tj? Now u dash tj, let us see how many approximations. Forward approximation is there. What is that? U of t plus h minus u of t by h. Now at j point, this is t plus h can be taken as tj here, tj plus h is nothing but, one can write j plus 1 minus uj by h, uj plus 1 means what? U of tj plus h. And next one is backward. What is that? u of tj minus u of tj minus 1 by h. That can be written as uj minus uj minus 1 by h. This is forward approximation, this is forward approximation, and this is backward approximation. And next one, central, u of tj plus 1 minus u of, okay, sorry, one can write minus h na here. You have to write tj minus h, you write, and here also you write this is u of tj plus h minus u of tj minus h whole by 2h, which can be written as uj plus 1 uj minus 1 by 2h. This is central difference approximation. These are the three approximations for the first derivative. Now among the three different schemes, the different schemes with the forward and backward, first two, okay, forward and backward are of first order, and the difference scheme with central difference, the difference scheme with central difference is of second order, okay. And the methods based on forward or backward differences, or you write like this: in the methods based on forward or backward differences, the I plus 1th stage solution are, yeah, okay, I plus 1th stage solution depends on ith stage solution, okay, or ith stage solution, this is in backward, ith stage solution depends on I minus 1th stage, okay. That is for your understanding. What is this one? The approximation is what? One can write forward. What forward gives? Forward approximation gives ui plus 1 minus ui by h equal to some fi, okay. One can write f of ti comma ui, okay. This implies ui plus 1 is completely depends on what? Ith term, so this is I plus 1th term depends on ith term. If I use backward, then ui minus 1 by h equal to what? F of ti comma ui. This also what? Ith term, that means ui depends on what? I minus 1th terms. Ui depends on what? I minus, only I minus 1 terms are there. Therefore ith term depends on I minus 1 term. That means when you write like this: when a method gives the solution at I plus 1th stage using only ith stage, that means it's a previous stage, only one stage, then the method is called single step method. Now in central difference approximation, we have what? We have we have what is the approximation ui plus 1 minus ui minus 1 by 2h equal to f of ti comma ui, f of 2i comma ui. What this gives? I plus 1 or ui plus 1 is in terms of what? Clearly in terms of ui minus 1 and a ui. Okay, that means I plus 1th stage depends on how many stages? That is I plus 1th stage. I plus 1th stage solution depends on ith and I minus 1th stage. I minus 1th stages. That means multi stages. That means therefore when in a method I plus 1th stage solution depends on ith, I minus 1th, etc. Okay, maybe I minus 2 also, etc. Depends on ith, I minus 1th stage, etc. stage solutions, then method is called multi-step method. Multi-step method. This is about single step method and a multi-step method. Next definition: local truncation error. The definition is the error in an approximation. Is the difference between the exact solution. What is exact solution? It is denoted by u tj plus 1 at t equal to tj plus 1, and the solution and the numerical solution, and the solution, that is nothing but approximate solution, and the solution value uj plus 1. See the difference. Exact solution is denoted by u of tj plus 1, and approximate solution is denoted by uj plus 1, determined by what is this uj plus 1 solution? Determined from a numerical method. Using exact arithmetic or using numerical method is called, that is difference between what? Exact and approximate, that is determined by numerical method, is called the local truncation error. Or it is sometimes it is also called as local discretization error. Okay, and is denoted by what is the local truncation error? tj plus 1 is nothing but the difference between exact solution at a tj plus 1 at the point j plus 1, simply called. This is j equal to 0, 1, 2 and so on. How many data points? If I take n, means 0 to n minus 1 means n. This is about local truncation error. That is difference between exact solution and numerical solution is the local truncation error. And the next one is convergence. What is the definition of convergence? Convergence definition is clearly the numerical solution contains errors, right? The numerical solution uj will contain errors. So the effect of these errors will will play an important role on the solution, right? Obviously the error plays an important role over the solution, and when a method is said to be convergent, a method is convergent if, as, see the definition, as more grid points are taken, that means number of mesh points are more, or one can write the step size h is decreased, the numerical solution converges to exact solution. Exact solution in the absence of round of errors. Round of errors means we have to round after some particular point. What is meant by convergence? Now that means when I increase the number of mesh points, what is actually here, what is h equal to b minus a by n? N means what? Number of data points or number of intervals. One can say number of intervals. When n is increased, n more means what? H less. That means when grid size, step size is very less, or number of data points are more, the numerical solution must be converges to exact solution. That is the meaning of convergence. And the next one is stability. What is meant by stability? A method is said to be stable. If the cumulative effect of all errors, including round of errors, is bounded. That means what is stability means, whatever the error, maybe round of error, local truncation error, all the errors must be bounded. Then method is said to be stable. And bounded in what condition? Independent of number of mesh points. Independent of number of mesh points. Okay, this is about stability. And the next one, in single step according to the different schemes, forward, backward and central difference scheme, we have the methods. The first method is Euler method. There are so many cases in Euler method. See, let us see. The first one is using forward difference scheme. For what is the equation? Du by dt equal to f of t comma u, or what is this simply can be written as u dash t equal to f of t comma u. We have, what is this? This u dash is represented by what? Forward difference scheme, uj plus 1 minus uj by h equal to f of tj comma uj. Okay, so one can write this is uj plus 1 minus uj equal to h into fj. Fj stands for what? Fj stands for, here fj is nothing but function at the point j, that is tj comma uj. Then what is this becomes? Therefore this implies uj plus 1 is equal to what? Uj plus h into f of tj comma uj. Tj comma uj is called, this method is called Euler's method, is called Euler method, is called Euler method. Euler method, in Euler method, what is that? Uj plus 1 is obtained by, is obtained using what? Obtained by using uj, fj and h. That is, the method is called explicit method. When j plus 1th term is obtained by previous term j, the method is explicit method. The method is explicit method. Explicit means what? J plus 1th solution is obtained by jth solution. And the truncation error in this method, let us see. The truncation error in the method is, in the Euler method is, what is truncation error notation? Tj plus 1 is equal to, what is the formula? Exact solution ut of j plus 1 minus numerical solution. This equal to u of tj plus 1 minus, what is at j plus 1? This is also j plus 1. What is Euler's formula? Uj plus 1 is nothing but what? Uj plus 1 is nothing but what? Uj plus h into f of tj comma uj. H into tj comma uj. That is equal to, let us expand every term in terms of Taylor series. One can write this is u of tj plus 1 minus, I can write this as u of tj numerical plus h into f of tj comma uj. Tj comma uj. Let us expand in this one, expand uj plus tj plus 1, u tj plus 1 in Taylor series. First one is u of tj plus h into u dash tj. Okay, next one plus h square by factorial 2 into u double dash tj, and so on. Okay, plus and so on, minus u of tj, right? Next minus what you will get? Minus h into f of tj comma uj, right? So this two terms gets cancelled. Next one, h into u dash tj plus h square by factorial 2 into u double dash tj, and so on. What is the last one? This minus h into, what is this differential equation? U dash t equal to f of t comma u. So what is this? F of tj comma uj equal to nothing but u dash. So one can write this is u dash of tj, u dash of tj. Remember this. What is this? U dash is equal to f of t comma u. So this f of tj comma uj is nothing but what? U dash of tj. So I have written here. Now these two terms gets cancelled, and what is the error remaining? H square by 2 u double dash tj, and so on. One can write this one as, therefore, after truncating the terms tj plus 1, considering only this term f u double dash of xi, one can write u double dash of xi, where xi belongs to tj and tj plus 1, xi less than tj and tj plus 1. Is that clear? Okay, and one can write, if we denote, let capital T is what? Maximum of the truncation error. The maximum error in what interval? Our interval, starting interval is what? T naught comma b, and capital M equal to maximum of this double derivative, maximum of u double dash xi, maximum of u double dash I over t naught comma b, right? Then what I am having? tj plus 1 is, that means this equal to h square by factorial 2 u double dash xi becomes what? This is capital T. If I consider maximum, then equality becomes less than or equal to h square by 2 of m, h square by 2 of m. Therefore the local truncation error the local truncation error is what order? What is this one? Order of h square, capital O, big O, order of h square, as when I decrease the step size, h tends to 0. This is Euler's method and it's a truncation error. This is final. Truncation error is what? Order of h square. Now, that is whatever the Euler's method is previously discussed, it is called forward Euler's method. Now, another Euler's formula, backward Euler's method. Backward Euler method. What is this is? What is our differential equation? U dash equal to f of t comma u with what condition? U of t naught equal to u naught is the initial value problem. Is the initial value problem. Okay. Then at t equal to tj, we have what is this? U dash of tj equal to f of tj comma uj. Now using backward difference for u dash tj, we have what is this? Uj minus 1 by h equal to f of tj comma uj, right? So what I'm getting, this is finally uj is equal to uj minus 1 plus h into f of tj comma uj. Now replace t equal to tj plus 1. Then what we have? This uj becomes uj plus 1 and uj minus 1 becomes what? Uj plus h into what is this? Tj plus 1 comma uj plus 1. Tj plus 1 comma uj plus 1. Okay. This formula is called backward Euler method. Is called backward Euler method. Okay. This is one short method. Next method is midpoint method. What is midpoint method? Consider the initial value problem. U dash t equal to f of t comma u with initial condition u of t naught equal to u naught. Okay. At the grid point t equal to tj, we have u dash of tj equal to f of tj comma uj, right? The differential equation. Now using central difference for u dash tj, we have what is the approximation? Central difference for the first derivative, uj plus 1 minus uj minus 1 by 2h. Already we derived this, f of tj comma uj. So what is this? Becomes uj plus 1 is equal to what? Uj minus 1 plus 2h into f of tj comma uj. This method is called, this is for I equal to 0 to n minus 1, is called midpoint formula, midpoint method or formula. And what is the truncation error? The local truncation error. Is what is that? Tj plus 1 is equal to exact solution minus approximate solution, right? That implies Tj plus 1 is equal to utj plus 1 exact as it is. And what is approximate solution? This is j plus 1. What is uj plus 1 formula from this midpoint formula? Uj minus 1 plus 2h into f of tj comma uj comma uj. Now let me write tj plus 1 equal to u of tj plus 1 means tj plus h minus what is this one, uj minus 1 means u of tj minus h minus 2h into what is this, f of tj comma tj. One can write this is the first derivative, u dash of tj. U dash of tj means because u dash of tj is nothing but f of tj comma uj, right? Now let us use Taylor series approximation. This is uj plus h into u dash j plus h square by factorial 2 u double dash j h cube by factorial 3 u triple dash j and so on, minus coming to this expansion uj minus h into u dash j plus h square by factorial 2 u double dash j minus h cube by factorial 3 u triple dash j and so on, minus 2h into u dash j. Finally, which terms are getting cancelled? uj term getting cancelled, right? Next one, this odd derivatives becomes plus and this is minus after multiplying. So what are the leftover terms? 2h u dash j plus 2h cube by 3 factorial u triple dash j and so on. And what is the last term? 2h u dash j. Now these two getting cancelled. So finally, what is the leftover term? H cube by this 3 factorial 6 means u triple dash xi I will write, neglecting the other terms, where xi belongs to what? tj minus 1 less than tj plus 1. Okay, so one can write this is less than or equal to h cube by 3 capital M3. What is M3 means? M3 is maximum over T naught comma B, right? Maximum over T naught comma B of modulus of u triple dash what is that? tj, modulus of this is u triple dash, okay, tj. So this is the truncation error. Therefore what is capital T? One can write this is capital T. So truncation error is of what order? Truncation error is of capital order of h cube, okay. This is midpoint method. Now based on the Euler's method, let us see the problems. Use the Euler method to solve numerically the initial value problem. U dash equal to minus 2t u square, and the condition is u of 0 equal to 1 with h equal to 0.2, 0.1 and 0.05 on the interval closed 0, 1 is the problem. Solution. What is the differential equation? The IVP is u dash equal to minus 2t u square. Here what is f of t comma u function? Minus 2t u square. This function, right side function, f of t comma u equal to minus 2t u square, right? Now the Euler method is what is the formula? uj plus 1 equal to uj plus h into f of tj comma uj. This is the Euler's formula. Take this as 1. Here what is the condition is given as initial conditions u of 0 equal to 1. Therefore what is t naught value? 0. This is t naught. Compare this one with the u of t naught equal to u naught value. T naught equal to 0 and what is u naught value? 1. Now case 1, what is h equal to how much? 0.2, And what is interval? From 0 to 1 I have to take h equal to 0.2. Therefore t naught equal to 0. What is t1 equal to? T naught plus h, that is 0.2. What is t2 equal to? T1 plus h, that is 0.2 plus 0.2, 0.4. And t3 equal to what? T2 plus h, that is 0.6. And t4 equal to what? T3 plus h, that is 0.8. And t5 equal to t4 plus h, that is 1. Finally we have to reach 1. So what are the grid points are? The grid points are t naught equal to 0, t1 equal to 0.2, t2 equal to 0.4, t3 equal to 0.6, t4 equal to 0.8, t5 equal to 1. Therefore what is j raised from? 0. J values are 0, 1, 2, 3, 4, 5. Therefore this equation for j equal to 0, 1, 2, 3 up to what? What? T naught 0, t1 0.2, right? Yeah, 0 is there, this value 0 to up to u5 you will get. Up to t5 what is the solution? u5. Therefore this equation is valid for up to 0 to 4 only. u5 is the last value. At t naught what is the solution? u0. At t1 what is the solution? u1. Similarly at t5 what is the solution? u5. From this we will get u5 when I put j equal to 4. So this is the last value. Euler's formula is valid with h equal to 0.2 for j equal to 0 to 4 only, right? Since I will write once again, since the grid points are t naught, t1 up to what? t5, the Euler method is uj plus 1 equal to uj plus h into f of tj comma uj is for j equal to from where to where? To get, I know u0 value, I have to get u1, u2, u3, u4, u5. So u5 means up to 4 only. Okay, this is my equation 1 like previous one. Let us move towards for j equals to 0. First thing, for j equals to 0, what I am getting? This equation 1 implies u1 you will get, this is u0 plus h into what? F of t0 u0. So that is equal to u0 value is 1, h value is 0.2, and what is this one? Minus 2. What is the formula? What is this one? 2. What is this function? Right side function is minus 2t u square, 2 t naught u naught square. Okay, so what is this? Is this implies u1 equal to 1 minus 0.4. What is t naught value? One can write directly. What is t naught value? 0. So this value is 1 since t naught equal to 0. Since t naught equal to 0, u naught value is what? 1. This is over. u1 means what? u1 means what? u of t1 equal to 1. What is t1 value? 0.2. u of 0.2 equal to 1. This is the first thing. And for j equals to 1, equation 1 implies when I put j equal to 1, this is u2 h into f of t1 comma u1. So what is this becomes? What is u1? u1 means now this value, that is 1, plus h value as it is minus 2 t1 u1. Okay, t1 u1 square. So what is this? 1 plus or 1 minus 0.4. What is t1 value? t1 is nothing but what? t0 is 0, t1 is 0.2. Okay, so this is 0.2 and u1 square means 1 square. So finally u2 value is 0.92. u2 value is 0.92. Okay, what is meant by u2? u2 means u of t2. u of t2 is nothing but u of 0.4 value is 0.92. u2 is nothing but like this. Okay, similarly j equal to For j equal to 2, I am getting from equation 1 u3 equal to u2 plus h into f of t2 u2. What is u2 value? This is 0.92 plus h value, and this is minus 2 t2 u2 square. So this implies u3 equal to 0.92 minus 0.4. What is t2? 0.6. And u2 square, u2 means what? 0.92 square. Okay, this implies totally, and this value is 0.78458. that is u3 equal to, that is u of t3. U of t3 means t naught 0, t1.2, t2.4, right? t3.6, t3.6, right? And t2 value here, what you will get, this is 0.4. U of 0.6 value is 0.78458. This is over. Next one, for j equals to 3, u4 equals to, equation 1 gives u3 plus h into f of t3 comma u3, that is equal to u3 value 0.78458, right, plus 0.2 h value minus 2 t3 u3 square. So this value 0.78458 minus 0.4, what is t3.6, and u3 square 0.78458 square, and this value is, this is u 0.6.8 now. So this value is 0.63684. Therefore u4 is nothing but u of t4. U of t4 means what? 0.8, right? 0.8 value 0.63684. Similarly, for j equals to 4, the final one, equation 1 implies u5 equal to u4 plus h into f of t4 u4, that is 0.63684 plus 0.2 into minus 2 t4 u4 square. So this value completely, after substituting everything, 0.50706. Therefore u5 means what? U of t5. What is t5? Is 1. This value is 0.50706. So up to 0, what is interval? 0 to 1. So we are getting up to solution 1, u of 1. This is with h equal to 0.2. Similarly, when, what is the next case? H equal to 0.1. When h equal to 0.1, okay, the grid points are, what is first one? t0 0. So obviously, what is t1? 0.1. Same equispaced data, add 0.1 for the increasing data points, 0.3, t4 value 0.4, t5 value 0.5, t6 0.6, t7 0.7, t8 0.8, t9 0.9, and t10 1. Therefore Euler method, what is that? uj plus 1 is equal to uj plus h into f of tj comma uj. This is equation 2. You take for what values of j? This is 0, 1, 2 up to last point is what? 10 we will get when I put 9 last value. So as usual, follow the procedure. For j equals to 0, you will get u1. For j equals to 1, you will get u2, and so on. For j equals to 9, you will get u10 value. Okay, like previous case, you apply this. Similarly, do it for h equal to 0.05. This is one small problem based on Euler's method. Next, let us take a problem based on midpoint method. Solve the initial value problem. Solve the initial value problem. U dash equal to minus 2t u square with a u of 0 equal to 1 using midpoint method. Using midpoint method with h equal to 0.2 over the interval 0 comma 1 over the interval 0 comma 1. Use the Taylor series method. Use the Taylor series method of second order to compute u of 0.2. Okay, now solution. What is the midpoint method? The midpoint method is what? Uj plus 1 equal to uj minus 1 plus 2h into f of tj comma uj equation 1. Okay, here what is the condition? Initial condition is given by u of 0 equal to 1, that is t naught equal to 0 and u naught value is 1. And what is f of t comma y, t comma u function, that is minus 2t u square. Okay, given h equal to what? H equal to 0.2. Therefore the grid points or mesh points are, first one t naught equal to 0 as usual, t1 equal to 0.2, t2 equal to 0.4, t3 equal to 0.6, t4 equal to 0.8 and t5 is 1, the last point of the interval. Therefore the midpoint method is uj plus 1 equal to uj minus 1 plus 2h into f of tj comma uj is valid for what values of z? 0, 1, 2, 3, 4 only, up to u5. So j must be 4 for the last value, and let us substitute one by one. Okay, and what is this? Is this is equal to uj plus 1 equal to uj minus 1 minus h value 0.2, so therefore this is 0.4, and what is this becomes? tj h is there, 0.4h tj uj square, so totally h value point, let us substitute h value also, and this is what? No, this is minus 2 is there, therefore this is 0.4, yeah, 0.4 included in that one, 2, and if I substitute h equal to 0.2, this is h equal to 0.8 tj uj square. This is equation 1 for j equal to, or 2, equation j equal to 0, 1, 2, 3 and 4. See, when j equals to 0, I will get, and one more important point, all of you remember, this is what? uj minus 1, but when j equals to 0, what is this becomes? u minus 1. U minus 1 is not at all a considerable point, therefore delete 0 also. So equation is valid for j equal to 1 to 4, this is very important point. Now when j equals to 1, what I am getting here? u2 value. See, when j equals to 1, equation 2 gives what? u2 equal to u0 minus 0.8 t1 u1 square where we do not know the value of u1. What is the meaning of u1? U of t1. What is t1 value? 0.2, 0.2. Therefore, given that, what is the given actually? Given that compute the value of u of 0.2 using Taylor series. Of what order? Of second order. Taylor series of second order. That is, what is the Taylor series formula? u1 is nothing but u of t1. U of t1 can be written as what? U of t0 plus h. So this is u of t0 plus h into u dash of t0 plus h square by factorial 2 into u double dash t0. Up to second order means up to second h square only. You consider up to h square only. This implies u of 0.2. u1 means u of 0.2. You can write u1 equal to, this is u of 0, right? h into t0 value 0, h square by 2 u double dash 0. And what are the given values here? Given u of 0 value is what? 1. It is given, first thing. And u dash, what is u dash? Is nothing but minus 2t. Okay, let me write in the next slide. Okay, what is the given? U of 0 equal to 1 value is over, and u dash of t equal to what? Ut of u square. From this, u dash of 0 value is what? 0. That means t value 0, right? Or one can write u dash of t0. You can write u dash of t0 equal to minus 2 into t0 u0 square. This is 0 since t0 value 0. So u dash of 0 value 0. Now coming to u double dash t, one more derivative. What is that? UV method. This is one term, this is another term. So first minus 2u square minus 2t into 2u dash, UV method. Therefore u double dash t0 value is what? Minus 2u0 square 2t0 2u0 u dash naught. That implies minus t. What is u0? This is nothing but u0 value 1 and t0 value 0, so 0. So u double dash t0 value nothing but u double dash 0 value is what? Minus 2. Therefore, what is u1 formula? U1, that is nothing but u of 0.2 Taylor series. First one u of 0. Okay, once again I am writing h into u dash 0 plus h square by factorial to u double dash 0. Let me substitute all the values. This is 1, h value 0.2, u dash 0 value 0, and h equal to 0.2 square by 2, u double dash 0 value minus 2. Therefore u1 value is finally 0.96. Therefore now u1 value is over. Now what is the formula? Equation 2 implies, what is that? uj plus 1 equal to uj minus 1 minus 4h tj uj square. Equation 2, this is for what values? J equal to 1 2 3 4. Now let us substitute one by one. For j equals to 1, equation 2 implies u2 equal to u0 minus 4h j equal to 1 t1 u1 square. Now I know every value. This is 1 4 and this is 0.2, t1 value 0.2, right? t1 value 0.2 and u1 value 0.96 square. So this entire value is 0.852544. Okay, now for j equals to 2, equation 2 implies u3 equal to This is u1 minus 4h t2 u2 square. What is u1 value? 0.96 minus this becomes 0.8, t2 value 0.4 and 0.852544 square u2 square. This entire value 0.7274139. Next, for j equals to 3, equation 2 implies u4 equal to u2 minus 4h t3 u3 square. Substitute all the values and u2, what is u2? This is 0.852544 minus 0.8, t3 0.6, u3 0.7274139 square, that is equal to 0.59855611. And finally, for j equals to 4, equation 2 implies u5 is nothing but u1, okay, that is equal to u3 minus 4h t4 u4 square. Substitute all the values and this is 0.498176, right? Therefore, let me write clearly, u1 means what? U of 0.2. U of 0.2 is what? 0.96. This is by Taylor series. This is by Taylor series. And next u2 is nothing but what? U of 0.4. This value is 0.852544. u3 0.6. This value is 0.7274139. Next value u4, I'm writing here, u4 is nothing but u of 0.8. This value is 0.59855611. And finally u5 is u1. This value is 0.49811176. This is one problem based on midpoint method.